December 7th, 1995. 10:47 p.m. A probe the size of a small car is screaming into Jupiter at 106,000 miles per hour. Its mission: survive 1 hour. Send data. Die. 57 minutes in, the signal spikes. Mission Control hears 3 words that don't make sense: unexpected, dense, layer. Then, silence. The probe died 22 kilometers deeper than physics said it could survive. It hit something that wasn't supposed to exist. And that impossible discovery connects to a controversy that exploded in 2022 when a Hollywood actor walked into a podcast studio and said something that made NASA scientists extremely uncomfortable. This is the story of what we got wrong about planets, and why Jupiter is about to rewrite everything. The crack in the story. In 2022, Terrence Howard sat across from Joe Rogan and made a claim. Not about movies, not about Hollywood, about planets. He said the way we're taught planets form is completely wrong.
So you believe that the sun is the origin of these planets?
Of all the planets. Every solar
solar system
within its solar system gives birth to all of these other planets. This is what Walter Russell had talked about. This is what Neil deGrasse and they attacked him for.
Within 48 hours, that clip hit 47 million views. Scientists rushed to Twitter. Neil deGrasse Tyson called it celebrity pseudoscience.
I recently learned I got name-checked by Terrence Howard on his recent appearance on Joe Rogan.
I reached out to Neil deGrasse Tyson. He was like, hey man, yeah, I'd love for you to come on my show, do my radio, do my TV thing. Would love that. I was like, yeah, but I've got something I want to introduce to you.
Articles appeared with headlines like, "Actor doesn't understand basic astronomy." Case closed. Except for one problem. Long before Terrence Howard ever spoke those words, government-employed astronomers had been saying the exact same thing. For over a century. Let me show you what they found. We're taught a simple story in school. After the sun formed, leftover dust slowly clumped together. Pebbles became rocks, rocks became boulders, boulders became planets. Gravity did the work. Time did the rest. It sounds logical. It fits on a textbook page. But there's a problem nobody mentions. The early solar system wasn't calm, it was a demolition derby. Objects weren't drifting gently, they were slamming into each other at 30,000 miles per hour. At those speeds, collisions don't build things, they obliterate them. Material should have shattered into finer and finer dust, not clumped into planets. Yet somehow, we're told it worked anyway. Then there's the orbital plane. Every planet circles the sun in almost the exact same flat disk, like grooves on a record. But gravity pulls equally in all directions. Random debris shouldn't organize itself into a perfect plane. It should scatter everywhere. And then there's the gas giant problem. We're told Jupiter and Saturn could only form far from the sun, where it's cold enough for gases to freeze. But astronomers keep finding hot Jupiters, massive gas giants orbiting closer to their stars than Mercury is to ours. According to the rules, they can't exist. Yet we've found hundreds. So either the universe keeps breaking its own rules, or the rules were wrong from the start. And that's where one man comes in. Dr. Tom Van Flandern, Yale-trained astronomer. 20 years at the U.S. Naval Observatory. His job wasn't to theorize, it was to measure. He calculated planetary positions so precisely that military navigation systems depended on his numbers. And those numbers didn't match the story. The sun holds 99.8% of the solar system's mass, but the planets hold 98% of its angular momentum. That's like a figure skater spinning with their arms extended, physically backward. Van Flandern noticed something else. The planets aren't randomly spaced. They're paired. Earth and Venus, nearly identical in size. Jupiter and Saturn, matching giants. Uranus and Neptune, ice twin siblings. But then there were the misfits. Mercury, too dense, wrong orbit. Mars, too small, too light, orbiting like it's lost. Pluto, behaving like a captured moon with no parent. Van Flandern reached a conclusion that destroyed his career. In 1993, Van Flandern published his findings in a peer-reviewed journal. Within months, funding for his research vanished. Conference invitations stopped. His papers were rejected without review. Colleagues who had worked with him for decades suddenly refused to return calls. By 1998, he was forced to resign from the Naval Observatory. Not because his math was wrong, no one could prove that, but because his conclusions threatened 40 years of textbooks, grant proposals, and academic reputations. He spent the last decade of his life self-publishing his work, watching as every prediction he made, hot Jupiters, fuzzy cores, orbital anomalies, was quietly confirmed by missions like Kepler and Juno. He died in 2009. NASA never acknowledged him. Mars wasn't a failed planet, it was debris. The asteroid belt wasn't leftover building material, it was a graveyard. And planets weren't built from dust around the sun, they were born from the sun itself. Which brings us to Jupiter. Because if something strange is happening in our solar system, it's happening there first. Jupiter is not what you think. Almost everything you learned about Jupiter in school is outdated. Not because your teachers lied, but because the truth wasn't known yet. For decades, Jupiter was called a gas giant, a failed star, a bloated ball of hydrogen. Simple. But that picture collapses the moment you look inside. Imagine descending through Jupiter's atmosphere. At the top, temperatures drop to minus 145 degrees Celsius. Ammonia ice collides with water vapor, creating storms the size of Earth that last for centuries. Lightning bolts 10,000 times more powerful than anything on our planet rip through clouds of methane and sulfur. But that's just the skin. Go deeper. Pressure takes over. Hydrogen gas, the lightest element in existence, gets squeezed so hard it becomes liquid. Not cold liquid, hot liquid. An ocean of liquid hydrogen 20,000 kilometers deep. That's deeper than Earth's diameter. And at the bottom of that ocean, pressure becomes so extreme that hydrogen transforms into something else entirely. Metallic hydrogen. To understand what this means, picture this. Take a hydrogen atom, the lightest thing in the universe. Now squeeze it with 3 million times Earth's atmospheric pressure. The electrons get ripped away from the nucleus. What's left conducts electricity like copper wire. Scientists have tried to create this in labs. They've succeeded for nanoseconds, before the equipment explodes. Jupiter has an ocean of this stuff 20,000 kilometers deep. That's like having an entire planet made of a substance we can barely create for a fraction of a second. And this metallic ocean does something extraordinary. It generates the largest planetary magnetic field ever observed, 20,000 times stronger than Earth's. For most of human history, Jupiter was just clouds. Beautiful, swirling, hypnotic clouds. But clouds hide structure. The first breakthrough came in 1994. A comet named Shoemaker-Levy. 9 slammed into Jupiter. Not once, 21 separate times. Each fragment struck with the energy of hundreds of millions of nuclear bombs. The explosions punched holes through Jupiter's cloud layer and hurled material thousands of kilometers into space. For the first time in history, Jupiter's interior was exposed. Astronomers around the world watched in real time as each fragment struck. The first impact created a fireball 3,000 kilometers high, visible from Earth with backyard telescopes. The explosion left a dark scar larger than our planet, a bruise in Jupiter's atmosphere that lasted for months. When fragment G hit the largest piece, it released energy equivalent to 6 million megatons of TNT. That's 600 times the entire nuclear arsenal of Earth detonated simultaneously. The shock wave rippled across Jupiter's entire hemisphere. Material from 1,000 kilometers deep was thrown into space. And for the first time, scientists could analyze what Jupiter was actually made of. Not what models predicted, but what was really there. NASA's Galileo spacecraft arrived just months later. It flew straight through the debris, through material that had been locked beneath the clouds for billions of years. And what it found surprised everyone. Water. Huge amounts of it. Not just traces, reservoirs. Enough to challenge everything scientists thought they knew about Jupiter's formation. But the real shock came in 2016. That's when NASA's Juno spacecraft arrived and began mapping Jupiter's interior with unprecedented precision. And what Juno found made no sense. Jupiter doesn't have a clean, solid core. It has a fuzzy core, a massive region where rock, metal, liquid hydrogen, and metallic hydrogen blend together with no clear boundary. Half the planet's radius is this strange, dense soup. That's not how a planet assembled from dust should look. That's how something looks when it forms under intense pressure, from the inside out. The probe that wasn't supposed to die. Let's go back to that probe. December 7th, 1995. The Galileo atmospheric probe begins its suicide dive. The mission plan was simple. Survive 60 minutes in Jupiter's upper atmosphere. Gather temperature, pressure, and composition data. Transmit everything back to the orbiter. Then die. Engineers expected the probe to fail around 24 bars of pressure, about 24 times Earth's atmospheric pressure at sea level. That's where the heat and crushing force should have destroyed it. But the probe kept transmitting. 30 bars, 40 bars, 50 bars. Mission control was confused. The probe was descending faster than predicted. Temperatures were spiking in ways the models didn't account for. And then, at 57 minutes, the signal changed. Pressure readings jumped. Temperature readings contradicted atmospheric models. And then, the probe transmitted something that didn't fit. Unexpected. Dense. Layer. 22 bars deeper than it should have survived. The probe went silent. It didn't fail because of heat. It didn't fail because of pressure. It hit something solid. In the mission control recording, you can hear the confusion. One engineer says, "That density reading can't be right. Run diagnostics." Another voice, "Diagnostics are clean. It's real." A long pause. Then, if that's accurate, we need to recalculate everything below 20 bars. The probe's final data packet contained measurements that contradicted 30 years of atmospheric models. Temperature and pressure weren't following the predicted curve. The chemical composition was wrong, and the density gradient, the rate at which material got thicker as the probe descended, was far steeper than physics allowed. It wasn't just unexpected. It was impossible. Unless Jupiter's interior wasn't what anyone thought. According to the accretion model, Jupiter's core should be buried deep. thousands of kilometers below the cloud tops. But the probe hit dense material far too high, which means one of two things. Either Jupiter's interior is far more complex than we thought, or the model of how Jupiter formed is fundamentally broken. When Juno arrived 21 years later, it confirmed the probe's dying message. Jupiter's core isn't a neat ball of rock at the center. It's diluted, spread throughout a huge portion of the planet's interior. Rock and metal mixed with hydrogen in ways that shouldn't be possible under slow accretion. But it makes perfect sense if Jupiter condensed rapidly. If it was expelled from the Sun as a massive molten blob, then cooled and collapsed under its own gravity. Think of it like this. If you slowly stack rocks in water, they settle in layers, heaviest at the bottom. But if you drop a blob of molten metal into water, it doesn't separate cleanly. It cools unevenly. It traps lighter material. It creates a fuzzy boundary. That's what Jupiter looks like. Not a planet built layer by layer, but a planet born in violence. What Juno found and NASA didn't expect. July 2022. Juno's 43rd orbit. The spacecraft detected something strange in Jupiter's magnetic field. An anomaly. A region where the field suddenly weakens, then spikes. Dr. Scott Bolton, Juno's principal investigator, called it a magnetic scar we can't explain. Then in March 2024, Juno's infrared camera caught something else. Deep in Jupiter's atmosphere, below the cloud layer, there are warm spots. Regions generating heat from within, not from the Sun, from Jupiter itself. The planet is radiating 1.6 times more energy than it receives, which means Jupiter isn't just a cold gas ball reflecting sunlight. It's an active heat engine, and we have no idea what's powering it. Some scientists say it's leftover heat from Jupiter's formation, still radiating after 4.5 billion years. But the math doesn't work. Jupiter should have cooled by now. Others suggest it's gravitational contraction, the planet slowly shrinking and converting gravitational energy into heat. But Juno's measurements show the heat distribution is uneven. There are hot spots in specific regions. Not uniform cooling. Targeted heat generation. And then there's the magnetic field anomaly. In 2022, Juno mapped Jupiter's magnetic field in unprecedented detail. What it found was shocking. Near Jupiter's equator, there's a region where the magnetic field suddenly reverses direction. It's called the Great Blue Spot, not because of color, but because of how it appears on magnetic field maps. No other planet has this. To understand how strange this is, imagine Earth's magnetic field suddenly reversing direction over the Pacific Ocean. But nowhere else. Compasses would spin wildly in one region, while working normally everywhere else. That's what's happening on Jupiter. Except the scale is incomprehensible. The Great Blue Spot magnetic anomaly is 24,000 kilometers wide, twice Earth's diameter. It's been stable for at least 20 years, which means it's not a temporary glitch. Something deep inside Jupiter, roughly 10,000 kilometers below the cloud tops, is generating a localized magnetic field that opposes the planet's main field. No accretion model predicts this. No computer simulation has reproduced it. It simply shouldn't exist. Earth doesn't have it. Saturn doesn't have it. It's unique to Jupiter. Dr. Kimberly Moore from Harvard analyzed the data and said something remarkable. This magnetic anomaly suggests Jupiter's interior is far more dynamic than we ever imagined. Something down there is still actively churning. Still active. Still evolving. After 4.5 billion years. And there's one more thing. Jupiter's Great Red Spot, A storm larger than Earth that's been raging for at least 400 years. We've watched it shrink and grow, change color, shift position. But here's what doesn't make sense. Storms on Earth are powered by the sun's heat. They form, they rage, they die, usually within days or weeks. Jupiter's storms should work the same way, but they don't die. The Great Red Spot has been continuously active since at least 1831, and possibly much longer. Where is the energy coming from? If Jupiter is radiating more heat than it receives from the sun, if its magnetic field shows active churning deep inside, if its storms never die, then Jupiter isn't a dead world slowly cooling. It's powered by something internal, something we don't understand, something that challenges everything we thought we knew about planetary evolution. If the fuzzy core is real, if the metallic ocean is generating unexplained heat, if Jupiter is still evolving after 4.5 billion years, then everything we thought we knew about how planets form doesn't just need revision. It needs to be rewritten from scratch. And the evidence is already there, orbiting 484 million miles away, waiting for us to look closer. Something weird is happening on Jupiter. And in 2030, when Europa Clipper completes its first deep scan, we're going to find out exactly what.